Motion. So, who can tell me, does anybody know anything about Sir Isaac Newton? Brandon.
Like he's sitting in a tree.
He sat under a tree.
Like apple fell on him and like he discovered gravity.
He fell on a tree. He sat under a tree, an apple fell on him, and he discovered gravity. Anything else we know about Newton?
No.
Anything else that Newton makes us think of? Fig Newtons. I'm so glad someone said Fig Newtons, because I worked really hard on the title of this next slide. So please, at least give me a little bit of a chuckle, a little bite of Newton. Okay, so a little bite of Newton instead of a little bit of Newton.
Why is there a black screen?
Because I've got writing underneath it. I didn't want you to see all of it at once.
Oh.
Yeah.
That was like a stud.
Okay, so this is Sir Isaac Newton in his younger years. Now, this is not a click picture of him. This is a painting. At this time, we didn't have photos. So this is not a, 100% this is what he actually looked like. This is an artist. He's sitting in front of them and the artist painted him. So there is some bit that may not be 100% true. Because can we trust the artist to 100%? No. There may be some issues. So a little bite or bit about Newton. He was born January 4th, 1643. So you need to write this down. Aw, man. Now, this is strike one against Newton for me. Not only was he born in January 4th, 1643, but that was the year that Galileo died. So he was born the same year that Galileo died. So I automatically strike one, don't like him. How long do you think Newton lived?
Probably about 50 years. 50-some years.
I got 50 years, 33 years. Apparently he's Jesus Christ. 63.
20.
68, 20. Did a lot of work in 20 years.
60.
I said 30 at first.
60 something.
I say it's
He died in March 31st, 1727, so he lived to be in his 80s.
That's a really long. That's older than my grandma.
That is a significantly long time back then, especially since this was during the time of the Black Plague.
What he did? Oh, how do you know die?
I'm guessing he was extremely lucky. So does anyone know what he would be, like what nationality he would be, Sir Isaac Newton Carson?
English or French or something.
Pick one.
English.
English. He was an English citizen. So Sir Isaac Newton was an English citizen. Okay, so he was an English citizen, and we need to go to our next slide, where we're going to talk about his education. I know, fancy stuff. Newton's education was interrupted. He didn't have a smooth and seamless education like we have. We start in kindergarten and we go straight through 12th grade. We don't take a year or two off. That's when the cops come after you. And then most of us, if we're going to go to college, we go straight to college. Now, some of us don't, but the majority of American citizens, if they're going to go to college, they go straight to college anymore right out of high school. So what happened to him was his mother kind of had a different view of college. Our parents, I know my parents specifically, what do they harp on us about in terms of college and education, Brandon?
Go to school.
Go to school. You have to go to school. You have to get an education. And by golly, you're going to do it, whether you like it or not. Josh?
My dad says you don't got an education in this day and age, you won't get a job.
Exactly. That's what they say. Now, Newton's mother, on the other hand, said, you're coming home and you're working the farm. And so she pulled him from school. And she made him come home and work the farm. Well, Newton didn't really enjoy working the farm, so what do you think he did? What do you guys do when your parents tell you to do something that you don't exactly enjoy? Procrastinate. We're going to go with the procrastination answer. So he procrastinated, and this is where the apple story comes in. So the way the story goes is that he was procrastinating. He ran off, as sometimes we do, and hid from his mother because he didn't want to do the work. And he was leaning against an apple tree. And some stories say that he dozed off, and some stories say that he was just sitting there thinking about things and different theories that he wanted to work on. And all of a sudden, an apple fell from the tree and plunk on his head. And eureka, it all made sense. Excuse me. Now, that is not how it actually happened. First of all, Newton was not the first to work with gravity. Galileo, who died the year Newton was born, actually has quite a few theories of gravity and a few experiments where he worked with gravity. And Newton expanded on those theories. So does Kepler. Kepler has theories on gravities and planetary motion. So Newton is not the first to deal with this. And Newton will not be the last to deal with this. Einstein deals with gravity. We still have scientists to this day trying to figure out gravity.
Why? I thought we have it pretty understandable.
We understand it on small scale. We understand it on medium scale. And by small scale, I mean like us to Earth ratio. Medium scale would be like planet to planet ratio. But when it comes to cosmos and the universe, there's still a lot that we're not quite 100% sure of. So, he wasn't the first to deal with gravity. And on the other hand, I've never known of a single instance, and I may be wrong, but I've never heard of a single instance where something just went like that and it totally made sense. Now, that's not saying that you don't just get an inspiration, but even with an instant inspiration, you still have to work it out and get your data and your support. But it makes a nice little story. Well, thankfully, Einstein. Who are we talking about? Isaac Newton. So thankfully, Newton had a friend who convinced his mother to send him back to school, and he eventually went to Trinity College, Cambridge. And that is where this picture is taken. He has a nice little statue that is located at Trinity College, Cambridge. Yes. Yes, it's typed. You need to write it. And so he went to Trinity College, Cambridge. And while there, they studied mainly, pretty much only Aristotle. Now, what did we say Aristotle was the father of?
Science.
The father of science. How long did Aristotle's beliefs hold science in its grasp?
Thousands of years. Over like 1,000 years.
Over 1,000 years, close to
1,900 years.
1,900, 2,000 years, depending on the science. Some of them lasted longer than others. And so Galileo, once again, died when Newton was born. Galileo proved Aristotle wrong on certain things. So Galileo had been born, lived, proved Aristotle wrong, and died. And Newton had time to grow up to go to college, and they were still teaching Aristotle's beliefs. They had yet to change. Now, does that seem kind of weird? It's actually pretty normal. Think of it this way. When I was in school, we had 9 planets. How many planets do we have now?
8.
But I guarantee you I can walk into any classroom, any science classroom, and find a textbook that tells you we still have 9 planets. I guarantee you, whichever textbook, 6th, 7th, or 8th grade that we have that deals with the planets, it's going to tell you Pluto is a planet. And it's been since I was in high school. We're not going to talk about how long ago that was, but it's been quite a long time.
That's just because they don't make new books.
That's not the only reason. I can walk into a county that has more money than we do and replaces their books more frequently, and you still have the same problem. Because it takes a long time for information to filter down into the schools.
So you had your sign up there?
Huh?
You had your sign up there?
Oh, honk if you think Pluto is a planet.
And your shirt that says, "Don't worry, I'm not a planet either."
Yeah, that's just because I think the whole debate is hilarious.
Wait, so if it's not a planet, what is it?
It is a dwarf planet, planetoid.
But still minor.
And no,
But
it's a discussion for another day. Okay, so he was a mathematician, a physicist, an astronomer, and an alchemist. And that we have already studied this, and we have stated that alchemy eventually transformed into what?
Chemistry.
Chemistry. That's a lot to do in 80 years.
Oh
Mathematician, physicist, astronomer, and essentially a chemist. And we're not saying that he just studied these things. He made breakthroughs in these things. He came up with theories, discoveries.
So if you lived like an extra 20 years, do you think everything would be different?
Possibly. He came up with his own math. He created a system of math. He came up with laws of motion. He came up with gravitational theories. He came up with, he enhanced Kepler's theories of planetary motion. And then he dabbled a little bit in chemistry. I don't think he did as much in chemistry as he did in math and physics and astronomy, but he did do some things in chemistry. Okay.
Oh, wait, that was
Watch the video. So, I said that his schooling got interrupted more than once. The first time was because of his mother. The second time is represented by this picture right here. What does this picture represent?
a bird.
Anybody know what that represents in our history? It's the only time in human history where more people died than were born.
Oh, Black Plague.
The Black Plague. Because of the Black Plague, his college was closed for 2 years. They did not have classes for 2 whole years. Now, the reason this represents the Black Plague, this is what the doctors wore. And so this hooked-nosed kind of beak thing, what they would do is they would put posies and different herbs and flowers in a satchel, like a cheesecloth kind of thing. And they would put that in the hooked nose, and they believed that by breathing through that kept them from getting the Black Plague. Now, we now know that that doesn't work. That the Black Plague is transmitted through bites of fleas and other such ways. But they didn't know that at the time. So that's how they were trying to keep from getting the Black Plague. If you've ever done the childhood rhyme, ring around the rose, ring around the rosy, pocket full of posy, ashes, ashes, we all fall down. That whole thing describes the Black Plague.
That's creepy.
The ring around the rosy describes the mark that you would have. Pocket full of posies was supposed to protect you. Ashes, ashes was of burning the bodies, I believe. And then we all fall down was because everyone died.
What's a posy?
Posy is a type of flower. So, we sing that all happy and back in the day it was all like, death. Okay. So during those 2 years that he was off of school, while we would be playing Xbox and, not doing school-like things, he was working on his own theories. And the math that we had at the time, he couldn't prove his theories with it. It just wouldn't work. So instead of just giving up and saying his theories weren't right, he made up his own math. Hence the meme. Can't prove theories without non-existent math. invents calculus. So if you ever have to take calculus, it's all his fault. Reason number 2 why I don't like this man. Cannot stand calculus.
Did you get that laugh funny or did you make it?
I made, well, I Googled that one. One of y'all needs to teach me how to make memes, because I have no idea how to make it. Another time, but yes. So, the interesting story with this one is he wasn't the only one to invent calculus. There were 2 men who invented calculus at the exact same time, continents apart. He was in Britain, England. The other man was on, like, Europe, the continental Europe. They did not talk to each other. Put it down. They did not talk to each other. They didn't even know each other existed, really. But the thing was that Newton didn't publish his works. He was afraid that he would be made fun of for his work. And then the other guy started publishing his. Well, Newton was more well known. So when Newton finally published his, the other guy was accused of plagiarism, even though he published first. And it started this huge feud that lasted until they died. Like, for the rest of their life, these men fought. And it even went as far as into their descendants. And basically, as far as I know, there are still people fighting over who actually invented calculus, whether it was Newton or this other guy. And they will get into heated debates, like sometimes even knock down, drag out, fight debates, simply over who invented calculus.
Well, either way.
I wish somebody
It's a matter of honor.
I wish somebody would listen to them or something. We don't have to take-
Now, Newton has a history of not getting along with other scientists. He's not exactly known as being a pleasant man. First, he has the debate over calculus and who wins that. Secondly, he had another fight with another scientist over his theories of optics and what you would see on light if you change the pressure in your eye. Well, this other scientist tells him his theories are completely wrong. So he takes what's known as a darning needle, which is this thing right here. It's a blunt needle with a huge eye. This is the eye of the needle. These things are fairly thick too. And he inserts it between his eye and his eye socket. So he's not puncturing his eye, he's going between his eye and the eye socket. And he pushes it back until he reaches the back of his eyeball. And he just wiggles it around to see what will happen.
He did this to himself?
He did this to himself.
Kind of gross.
And he reports seeing black and white spots and random bursts of colors. So basically what he did was the equivalent of taking the heel of your eye and pushing it against heel of your hand and pushing it against your eye, and you know how you see those like stars? That's basically what he did. But he did this to prove his point. And this is another scientist that he had a feud with until they died. So he was not exactly easy to get along with. All right, laws of motion. How many laws of motion do we have?
3.
3. The first law of motion has another name. It is called the law of inertia. And it is basically says, it's the longest law we have, an object at rest will stay at rest, and an object at motion will stay at motion unless acted upon by an outside force. This is the longest one we have. And yes, you will eventually have to be able to identify these. So an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an outside force. After the first law comes second law. This one is a formula, hence why math comes in. The second law tells me the relationship between force, mass, and acceleration is that force equals mass times acceleration. So if my mass stays constant, as I increase the force on an object, it will accelerate. The more force I apply, the faster it accelerates. The less force I apply, the slower it accelerates. That would be the tardy bell. And the third law, for every action there is an equal and opposite reaction. That is what enables you to sit in your chair. As you push down on your chair is pushing up on you, and that is why you do not go straight down to the floor. Personally, I'm kind of glad of this law. Helps me walk, helps me open doors, lets me sleep in my bed, lets me sit down so I don't have to stand all the time. Sometimes it fails me, like when I slide on ice. But most of the time, it's good. We have a couple more things to write, and then we'll be done. Can I switch it? Boo. Y'all are slow. Okay, so my second law tells me that force is equal to mass times acceleration. So what we need to write down is our units for these. The standard unit for acceleration is meters over second squared. So if I am given acceleration in anything other than meters per second squared, I have to convert it. So if I'm given it in kilometers per second squared, what do I have to do?
Is that an S or a 5?
That's an S, second. Like it's unit of time. If I'm given it in kilometers per second squared, what would I have to do? What did I just tell you I'd have to do? Starts with a C.
Convert.
Convert it. What's it mean to convert it? Convert it. To change it. So I'm going to change it from kilometers to meters. What if I tell you meters per hour squared? What would I have to change it to? Meters per... I'm in meters per hour. I need to change it to
Second.
meters per second. The standard for mass is kilograms. So if I were to give you grams, what would you have to change it to? Kilograms. And the force is in newtons. So N equals newtons, which is the same thing as 1 kilogram times 1 meter over 1 second squared. So when I have that apple, it is a newton. So if I were to just let it drop,
They named that, Dan.
yes, they named that after Sir Isaac Newton. If I were to let it drop, that what you feel is the force of 1 kilogram, so it weighs 1 kilogram, accelerating at 1 meter per second squared. So every second that it drops, it's going an additional meter per second. So if it drops 1 second, it's going a meter per second. If it drops 2 seconds, its speed is 2 meters per second. If it drops 3 seconds, its speed is 3 meters per second. So the higher that I drop it from, then when it hits your head, it's going to be going faster or slower? Faster.
Like, I know, I can't remember what it's called, but like, after like a certain speed, like, say you're skydiving, you like stop gaining speed. Like it's like 100 something.
I'll have to look that one up.
I can't remember what it's called, but like after a while, you stop accelerating.
Okay, so write this down. I don't know why you packed up. This is a sample problem, real quick. A car has a mass of 1,500 kilograms. If it accelerates at a rate of 3 meters per second, what is the net force acting upon the car? So am I going to have to convert any of my units?
Yeah. No.
No. I was easy on you this one. I gave you it in the standard units. So the way that we would write these when we're doing these is the first thing we need to do is write down what we know. So what do I know?
1,500 kilograms.
The mass equals 1,500 kilograms. What else do I know?
Traveling 3 meters per second.
3 meters per second squared is my what?
Newtons. No.
It's meters per second squared.
Acceleration.
Acceleration. And what am I trying to figure out?
What is the force on the car?
So what formula do I have that has mass, acceleration, and force in it?
Newtons.
Newtons isn't my formula, that's a unit. What's my formula? What's the relationship between these three?
F is like M times A.
F equals M times A. So I don't know what F is yet, so I'm going to leave that as F. But I do know what M is, so what am I going to put there?
1,500 kilograms.
1,500 kilograms. That should not be a dot. And I know what A is. Hold on. What should I put there?
3 meters per second.
Don't pack up. Still right. I'm not dismissing you yet. So what is 1,500 times 3?
4,500. 4,500.
And I measure force in
Newton.
newtons. Okay, one last thing to show you real quick, just an interesting little thing. This is the death mask of Sir Isaac Newton. So this is what he actually looked like. And at this note, you are dismissed.